Okay, here we go. The moment you've been waiting for. We're going to start finding unit circle values based on all this stuff we know. So what I'm going to do is go through two different ways to approach this. And there's, as everything, multiple ways. Because you're going to start seeing, like on that worksheet 2-2 that we've got, it's just got a whole bunch of questions where it's going to say, all right, what is the value of these particular trig functions? And you're going to be expected to find them very quickly. So let's talk about way number one. All right, if I just said, okay, what's the sine of 120? And you're thinking, what the heck, 120? How am I supposed to figure that? Well, here's what you can do. Here's one way to approach that. You say to yourself, all right, 120, what is the reference angle? This comes up so much, reference angle. You'd say, oh, reference angle, that's in the second quadrant. So the reference would be 180 minus 120, and I'm not going to write this every time. So the reference is 60. Oh, so this is a 60-degree angle. The reference is 60 degrees. So for 60 degrees, opposite over hypotenuse, 60 degrees, opposite over hypotenuse, because that's my reference, is root 3 over 2. Then you have to say to yourself, okay, what is it, positive or negative? Positive or negative? Well, you already told me it's in the second quadrant, and in the second quadrant, sine is positive. So you're done. Over here, you got 315. Here's a quick shortcut. Anytime we're doing these problems and it ends in a 5, it's a unit circle problem that ends in a 5, its reference is going to be 45. But 315 is definitely fourth quadrant. So 360 minus 315. So the reference is 45, which is what I already told you, because anytime it ends in a 5, the reference is going to be 45. So you say, oh yeah, 45 degrees. So the cosine's 1 over root 2. So 1 over root 2, which we always know converts to root 2 over 2. Uh-oh, fourth quadrant. Oh, cosine's positive in the fourth quadrant, so it stays positive. Maybe I gave you too many positives on this. Tan of 210. Oh man, 210. I don't know what its reference is, but I do know 210 is definitely third quadrant. It's bigger than 180. So third quadrant, so 210 minus 180. So the reference is 30. Okay, so the reference is 30. So I look at 30 degrees and say, okay, what's the tan of 30? So tan would be opposite over adjacent. So that'd be 1 over root 3, which we know cleans up to root 3 over 3. Third quadrant. Oh, tangent in the third quadrant is positive, so it stays positive. So like I said, I probably made too many positive ones so far. Uh-oh, now we're into radians, 5 pi over 3. Well, hopefully at this point, you know that 5 pi over 3 goes into the fourth quadrant. And so far, we're just doing easy ones. 5 pi over 3 is in the third quadrant. So you're saying, oh no, what's the reference angle for 5 pi over 3? Well, third quadrant would be 2 pi minus 5 pi over 3 equals pi over 3. And then somebody yells at me and says, wait a second, every time it's in 5 pi over 3, 4 pi over 3, anything pi over 3, as long as it's a reduced fraction, anything pi over 3, the reference angle is going to be pi over 3. So 7 pi over 3, 11 pi over 3, 10 pi over 3. The reference is always pi over 3. So our reference is pi over 3, which we know goes with 60 degrees. So cosecant of 60, pi over 3 goes with 60. Cosecant would be hypotenuse over opposite. So 2 over root 3, that's the annoying one. That makes 2 root 3 over 3 when you clean it up. Uh-oh, it's fourth quadrant. And in the fourth quadrant, cosine and its reciprocal are positive. Everyone else is negative. So cosecant is negative in the fourth quadrant. 5 pi over 6. Well, here's another shortcut. Anything pi over 6, as long as it's a reduced fraction, anything pi over 6, the reference is always pi over 6. If you wanted to prove it to yourself, you'd say, okay, second quadrant. So pi minus 5 pi over 6. Oh, what do you know? That does equal to pi over 6. So my reference is pi over 6, which conveniently, that's 30 degrees. Pi over 6 goes with 30. Pi over 6 goes with 30. So let me see. Secant would be hypotenuse over adjacent. So what do you know? It's that 2 over root 3 again. So 2 root 3 over 3. Uh-oh, you just told me it was second quadrant. In the second quadrant, only sine and its reciprocal. Second quadrant, only sine and its reciprocal are positive. Everyone else is negative, so that guy gets a negative in front. Cotan 3 pi over 2. So you're like, uh-oh, 3 pi over 2 is not one of our specials. 3 pi over 2 is this guy down here. It's a quadrantal. 3 pi over 2 is a quadrantal. Well, this is when we got to remember the points. You'd say, oh, cotan. So let me see, there's X and Y. So cotan of theta, as we've discussed, is X over Y. So cotan would be 0 over -1, which is 0, based on that point right there. So this is one way to approach these problems, one way to approach these problems. And I'll do a separate one on another way to approach these problems.